Our next question is really similar to the last one, except now we have 2x squared plus 15x plus 20. So I'm going to write this out. We have x plus 6 going into 2x squared plus 15x plus 20. Now, this part of the directions where it says q of x plus r over x plus 6, we're going to kind of ignore that for now. We're just going to do the polynomial long division, and we'll come back to that. So as always, we start and we say how many times does the x go into the first term, which is 2x squared, and that's 2x times. If you want more of an explanation, it's on the other page. Then I multiply what I wrote, the 2x, times the x plus 6, and I get 2x squared plus 12x, and I subtract. Change the signs, and I get 15x. This cancels. 15x minus 12x is 3x, and then we bring down the 20. Then we say how many times does x go into 3x? That's 3 times. Multiply it out. We get 3 times x is 3x. 6 times 3 is 18. And this time we do have a remainder. We'll still, I think we can kind of see it, but we're still going to follow those steps for subtracting. That cancels. This becomes negative, so we have a remainder of 2. Now, to write it in this form, my answer to a division problem like this, or any division problem, is called the quotient. So q of x just means whatever quotient I got. And we could think 2x plus 3 is a function, right? I could graph y equals 2x plus 3. That's why they have it in function notation. And then basically what we have left is we have 2 left. And just like on the other page how we had 3 left, so we wrote 3 out of 7, here we have 2 left, so we write 2 out of x plus 6 because x plus 6 is what I was dividing by. This is called quotient remainder form, where we have the quotient and then the remainder in a fraction. Now this one, similar question, is x plus 6 a factor of 2x squared plus 15x plus 20? The answer to this one is no, because there was a remainder. In general, if a function b of x, so something we're dividing by, is a factor of another function a of x, the thing that we're dividing into, the remainder when they're divided will be 0. We're going to do some more practice with polynomial long division for the rest of the lesson. We'll also answer some questions about if things are factors or not. So we have our first 2 problems down here. Now at the Algebra 2 level, you usually will see like what we're doing this unit that will have cubics or quartics that we're dividing into. So that's what we see in our first example. So we have x cubed minus 4x squared minus 2x plus 6. And we're dividing x plus 2 into that. So I'm going to go pretty slow through this one. Our first thing is how many times does x go into x cubed? If I want to write that on the side, I can. If I subtract exponents, I get x squared, right? So x goes into x cubed, x squared times. And then we multiply. So x times x squared is x cubed. 2 times x squared is 2x squared. Here's where things get a little fancy because we have to think about negatives. So we're subtracting, make it positive, make that negative, change the sign here. So here, when we subtract, which is not really something that happens with integers, we get a negative 6x squared. Okay, so when you were in elementary school and did long division, we didn't really ever have negatives to worry about in the problem, but we do with the polynomials. Bring down the next one, so I have minus 2x. Back to the process repeats. So how many times does x go into negative 6x squared? That's negative 6x times. And I'll show that one more time. Negative 6x squared divided by x would be negative 6x. So it's really a division problem that's answering that question. Some people can do it in their heads. If you need to write it down, that's totally fine. So multiplying out now, negative 6x times x is negative 6x squared. 2 times negative 6 is negative 12x, and we subtract. Change all the signs, so everything becomes positive now. Negative 6x plus 6x squared, negative 6x squared plus 6x squared cancels. Negative 2x plus 12x is 10x. And then we bring down the next number, which is a positive 6. So this is our last step, right? We've brought everything down. X goes into 10x 10 times. Okay. Then I multiply it, so x times 10 is 10x. 2 times 10 is 20. And we will subtract. So this is also a little weird. We actually have a negative remainder here because 6 minus 20 is negative 14. So this is remainder negative 14, which is not something that ever comes up, once again, with those integers, but with polynomials. And once we look at the next lesson, it'll also even make a little more sense why it would make sense to have negative remainders. For now, we're just saying it works. Our second two parts, the first part was to simplify the following expressions using polynomial long division. The second part is to, based on your answer, determine if the divisor b of x is a factor of the dividend a of x. So basically we're just saying, did we find that it was a factor? The answer is here we have a remainder. So the answer to part B of this is no. And then the last part, part C up in the directions, is that we want to write it in that quotient remainder form. So my quotient is x squared minus 6x plus 10. You can write it two ways. I can write plus negative 14 over x plus 2 because negative 14 was my remainder and I put it over the number I was dividing by, right? Or I could just move that negative sign and make it minus 14 over x plus 2. Either way is fine. So let's move on to the next one. Now with polynomial long division, just like when you're adding numbers or dividing or multiplying, when you're just working with integers, like bigger numbers just make the problem longer. They don't really make it harder. So this one we do have a quartic up top, so it is going to take a little bit longer to do, but not necessarily harder. So we'll write this one out. And as I said, I'm going to go a little faster on this one, but you can go back and watch any of the first three examples I did if you need more help. So 3x goes into 3x to the fourth x squared times. Multiplying that out, oops, x cubed times. Okay, so 3x goes into 3x to the fourth x cubed times because I need x cubed to get up to x to the fourth. I don't need a 3, it's already there. So I multiply it out, 3x times 3x cubed is 3x to the fourth. Negative 2 times x cubed is negative 2x cubed. Then we subtract, and we'll change our signs. Positive, negative, positive. Cancels as expected. And we're going to get, when we negative 5x cubed plus 2x cubed is negative 3x cubed. And we're going to bring down the next term. So that's plus 2x squared. And then our process repeats. So 3x goes into negative 3x cubed, negative x squared times. Multiply it out, 3x times negative x squared is negative 3x cubed. Negative 2 times negative x squared is positive 2x squared. And I subtract, and on this one we can kind of already see it, hopefully, that everything cancels, which is kind of weird, right? So that cancels, that cancels. So what we would do is we'd bring down the 3x, but we need two terms so that when we multiply it out, we have something to subtract from. So I'm going to bring two terms down, and that's going to set me up for the next step. So 3x goes into 3x one time. 3x times 1 is 3x. Negative 2 times 1 is negative 2. And when I subtract, change all the signs, that cancels. And that also cancels. So this one we have a remainder of 0. Now the fact that all of this, the terms canceled on this step kind of goes along with the fact that I don't have an x term in my answer. I kind of skipped from x squared to just the constant, so that does kind of go together. So answering my questions, part B, we had no remainder, so yes, 3x minus 2 is a factor of this polynomial. And then C, we can't really write it in quotient remainder form, so we're just going to write our answer because there is no remainder, so we just would say that's the answer.